All right, so as we get into our last chapter here, we're going to be looking at differential equations. We're going to look at separation of variables. We've already been doing this for the most part. This is just a little more formal. We've got a lot more tools to work with now that we've done our transcendental functions. So we're just going to look at this. There's not much to it, so I'm just going to do as many examples as I can. I'll do about 10, 15 minutes of those. And then if you got any questions, please feel free to contact me, email, phone, text, whatever you need to do to get this figured out. So let's just get started here. We can see here that we have our typical differential equation dy dx equals a function of f over a function of y, and we need to separate it. We need to get all the y's on one side and all the x's on the other. So just be very, very careful to make sure that you follow all your rules. Don't break any rules just to separate your variables. You got to follow all the math rules. So we see here we have dy dx and 2x over y. We're going to move the y over here and the dx to the other side. So y's will almost always be on our left. Dx's will almost always be on our right. So when we do that, we get y dy equals 2x dx. Then we're going to integrate both sides. We get 1/2 y squared equals x squared plus c. We only need 1 plus c because we can always just combine the constants of integration there. So we'll just use 1 plus c on one side. Try to integrate at the same step so that our equal sign can be true. Now, that is an answer. Typically, though, we want to solve for y. So we would multiply by 2 first. Y squared equals 2x squared plus. Now, you can do the 2c if you'd like. Like I said in the past, I like that constant just to absorb anything that happens to it. So just because a bigger constant or smaller, depending on the math. In this case, we're doubling the constant, so we have a new constant c. But it's still just a constant. Once we get to our general solution, which is our next step here, we're going to take the square root. We get plus or minus the square root of 2x squared plus c. This is, remember, our general solution. Everything that has this derivative will have this general solution of some form with its location will determine c. It'll also determine the plus or minus in this case. Once you start solving and figuring out what c is, that c has to be locked. Okay, so there's no more absorbing things once you start solving for c. So that's the basic idea. We're just going to see as many examples as we can here. So here there's no x's. We have dy dx equals y squared. So we divide by y squared. Remember, we can't subtract because that would, if we subtracted, it would look like this. And then if we multiply by dx, we would get dy minus y squared dx equals 0. And that doesn't split up our variables at all. So that's not the way to go. We're going to divide. So we get 1 over y squared dy equals dx. Let's rewrite this so we can do calculus with it. So it's y to the negative 2 dy equals dx. Now we'll integrate. Add 1 to the power, we get negative 1. Multiply by the reciprocal, negative 1. And we get, this is the integral of 1, so x plus c. We will multiply by negative 1, so y to the negative 1 equals negative x. You can put a minus c or plus c here. Again, that c can absorb that. And then the reciprocal, so y equals 1 over, you can do negative c minus that, or negative x minus c. Or if your c was positive, you could have done c minus x if you want it to be pretty and have one less sign. Either way is fine. All right, here's the next one. Throwing in a little bit of trig. Again, doesn't do anything. Watch this plus sign. Again, it's not going to do anything in this case because we're just going to multiply by our denominator. Again, we're getting rid of fractions, so that's okay too. 3y squared dy equals x plus sine x dx. Integrate. You get y cubed equals 1/2 x squared minus cosine x, and then still just the plus c. Take the cube root. Remember, for cubes or any other odd power, we don't do a plus or minus. 1/2 x squared minus cosine x plus c. So there's that. More separation of variable. Here we have dy dx equals 4y. We have some options. We can either do 1/4y dy dx, which is okay, but now we've got a 4y there. I typically leave the constant on the other side, so I would do just divide by y and get 1/y dy equals 4dx. Because this I would technically need to do a u substitution. Here I know this one. This is the natural log of y. And this would be 4x plus c. Now this gets to become interesting. We need to solve for y. So the first thing we're going to do is we're going to get rid of the natural log. So each one of these sides will be the power for e to that power. That reduces, and we get the absolute value of y equals e to the 4x plus c. Okay, so moving over here, we'll jump up here. This can be separated. We can have e to the 4x times e to the c. Well, e to the c is just another constant, so this is now a bigger c. So we can have absolute value of y equals c e to the 4x. Well, absolute value just means that the y can either be plus or minus the other side. Well, c can absorb the plus or minus sign, so y equals some constant, plus or minus. It's possibly a big number because it's e to the some power times e to the 4x. So that c is something, okay? But this actually happens quite often, so we're going to see that when we have this natural log stuff and we have the e to the something plus c, we're going to end up having this constant multiplier in front instead of a plus c. So let's look here. All right, we got xy. So we're going to leave x there, bring the dx over, and divide by y. So we get 1/y dy dx. So again, we're going to have a natural log on the left side. And x dx. So natural log of y equals 1/2 x squared plus c. Very similar to what we just did up there. We're going to get absolute value of y equals e to the 1/2 x squared plus c. Remember, this c comes down in front, and the absolute value can be absorbed by that c. So I would allow you to go straight to c, e to the, and then we can do x squared over 2 if you'd like. And then it looks really pretty. Moving on. Slightly different. We have du dt equals e to the u plus 2t. Well, to separate those, we need to first write this as e to the u times e to the 2t. Now, I want my u's on the left, and my t's will be on the right. So I get 1/e to the u du equals e to the 2t dt. So I'm going to rewrite the left side just a little bit. We have e to the negative u du equals e to the 2t dt. Then we're going to integrate. We've seen this pattern quite a bit. I hope you've caught on. I will allow you to use this if you've caught on to the pattern. We have e to the negative u. We're going to multiply by the reciprocal, -1. Same thing here. E to the 2t, we can multiply by the reciprocal, 1/2. So as long as it's linear, as long as this variable is linear, you can do that pattern there and get a plus c. All right, we got to solve for u. So the first thing we're going to do is get rid of the negative sign. We have e to the negative u equals -1/2 e to the 2t plus c. Again, absorb the negative sign in the c. We're going to take the natural log of both sides. So we get negative u equals the natural log of negative e to the 2t over 2 plus c. And then negative sign again, so u equals negative natural log negative e to the 2t divided by 2 plus c. That is not a pretty problem, but we can do it. All right. Here's one that's a little, it looks easy, and then you have to take a second look, and it's a little bit harder. We see we have some t's and x's, and here's two tx to combine. So we really need to separate our t's and our x's. And the way we're going to do that is, we got 4 things here. We're going to group and factor. So dx dt, take our first group, 1 plus t. Take our second group, I'm going to add them and put the negative x minus tx on the inside. There's nothing in common in the first one, or we can write it like this, 1 plus t, and then minus 1, no, minus x, sorry. X is what's common there. We get 1 plus t. So then we can take the t out, or the 1 plus t out, and that leaves 1 minus x. Now we can separate them by dividing. And we get 1 over 1 minus x dx equals 1 plus t dt. All right, so we're going to integrate. On the left side here, we would have u equals 1 minus x, du is negative dx. So we get a little bit of negative sign going on here. We have negative integral of 1 over u du equals, integral of 1 is t, integral of t is plus 1/2 t squared plus c. Jump up to the other side here. Integral of 1 over u with the negative sign in front, so negative. All right, let's move the negative sign to the other side while we integrate. So we're going to make this negative and get natural log of u, which is 1 minus x. Okay, now the negative sign's on this side, so minus t minus 1/2 t squared plus c. We're going to do the e thing. So we have 1 minus x on the left, e to the negative t minus t squared over 2 plus c. Well, that e to the plus c at the end here, remember that brings a constant in front. So we have 1 minus x equals c, e to the negative t minus t squared over 2. C will absorb the plus or minus sign. E to the negative 2t, same thing. Add 1, or subtract 1. Negative 1. And we get this.